Thanks for coming, everybody. Today, I'm going to talk about the July floods that hit Vermont in 2023 and 2024. And we chose these two events because essentially they're in the same season, even the same month, even the same day. And we can imagine that other factors other than rainfall, distribution and intensity, and magnitude might account for differences that we see in impacts from this flooding. We can imagine that land use changes are pretty minimal over the year spanning these two events. And we are not having to deal with the compounding effects of, say, frozen ground or snowmelt dynamics, or change in leaf on, leaf off status. So it kind of made an ideal comparison to look at these two July floods and really restrict our focus our attention on the rainfall differences in distribution and intensity. This is a companion talk to next week's talk, which will be given by Rebecca Deal, examining some of the landscape factors that might be in place here in Vermont to offer differences in flood resiliency and differences in ability to attenuate these floods. So we kind of designed these two talks to run sequentially. Okay, and it's not advancing. Should I use the mouse? We're just gonna try and troubleshoot some slide advancing here on the fly.
Maybe you can click that okay also, right?
Yeah, and then just click back and
Interesting. There we go. Whatever you did. Was that the right arrow or the down arrow?
The right arrow.
The right arrow, okay. There's several members of our research team that have contributed to the analysis that I'll show you today, and many of the plots, particularly the top row of students and technicians, have been really instrumental in preparing some of the plots that you'll see today. First, let's talk a little bit about the rainfall that drove these events. In July of 2023, flooding resulted from rainfall that persisted over about a 48-hour period of time and was widespread across the state of Vermont. And this was a somewhat unexpected event that resulted from a combination of very high levels of moisture in the atmosphere and an atmospheric blocking pattern that slowed the progression of the low pressure zone over Vermont. 3 to 9 inches of rain fell over a 48-hour duration, and this rainfall combined with antecedent soil moisture to generate lots of runoff that resulted in flooding impacts. This is a gift from the National Weather Service that helps us kind of visualize the distribution of that rainfall over the 48-hour period. And then in 2024, the July event was associated with the remnants of tropical cyclone Beryl, which came ashore in Texas as a Category 1 hurricane before it weakened and migrated to the northeastern US. And it interacted there with a near stationary front, and the atmosphere again had record amounts of moisture, precipitable water in excess of 2 inches, and training thunderstorms dropped between 3 and 5 inches of rain over a duration, this time of less than 24 hours. Locally, up to 6 and 7 inches of rain over some communities fell in less than 12 hours. So a very different intensity of rainfall for the July 2024 event. So relying on the CoCoRaHS rainfall gauging network, we can plot precipitation totals for these two events and compare them side by side. I was helped with these figures by Lauren Waters, our REU that's working with us from the Civil and Environmental Engineering Department. And basically the little dots that you see are the rainfall gauges of the CoCoRaHS network, And we interpolated between them using inverse distance weighting to generate these maps. And the two maps are using the same scale for total rainfall. So that salmon color is indicating between 4 and 5 inches of rain, and the white blobs that you see, the white areas, are more than 7 inches of rain. So we can see from these plots that the 2023 event involved generally greater amounts of rainfall than 2024, partly related to that longer duration of rainfall, 48 hours. And we can see that the axes of major precipitation are different for each storm, extending more north-south along the eastern flanks of the Green Mountains on the left in 2023. But in 2024, it was a little more localized to that northern part of, north central part of Vermont, and had a west to east axis of highest precipitation. So different in terms of their distribution, as well as their magnitudes and durations. We can take these two maps and actually difference them, and I'll call this a rainfall of difference map, again created by Lauren Waters. Basically, what we're seeing here is the difference between the rainfall, total rainfall in each year. So the blue shaded areas saw more rainfall in July of 2023, whereas the red shaded areas saw more rain in 2024. So locally, for communities like St. Johnsbury and Linden in the Northeast Kingdom, or Heinsberg and Starksboro in West Central Vermont, the July 2024 event generated a lot more rainfall, and as a consequence, there were greater impacts in those communities. We can see the difference between the events also in the effect on lake levels in Lake Champlain, which received a lot of this runoff in the western and northwestern parts of the state. So here's the signal of Tropical Storm Irene from August of 2011, which previously had been the biggest storm we'd seen in a while. Runoff from Vermont rivers caused the stage in Lake Champlain to remain elevated for more than a month. And the July 2023 event in orange tracked pretty closely to that Irene signal and was even more elevated because the lake level was just a bit higher to start with than it was in Irene. But in July 2024, from just a couple of months ago, lake levels were not quite as affected because there was less total rainfall draining from those Lake Champlain Basin watersheds than in the 2023 event. How about the response of rivers to these two events and the difference in magnitude? So river responses in 2024 were quite different. So in the Passumpsic River, for example, river stage was about 7.5 feet higher in 2024, leading to impacts that we saw in St. Johnsbury. And for example, the Mad River was 4 feet higher in 2024, leading to more damages. Those happened to be localized in the Moortown area in the lower part of the watershed. But on the other hand, river stages in the Winooski, for example, were lower in 2024, 7 feet lower in Montpelier and 3 feet lower at Essex Junction, where stages were lower than in July of 2023 or lower than Irene in 2011. When we now overlay the river response on a backdrop of that interpolated precipitation, not surprisingly, we see larger, more extreme floods at gauges with upstream drainage areas that are draining some of these intensively rained upon areas, those areas that received higher rainfall totals. So each of these dots on these maps represent the USGS river streamflow gauges in the Lake Champlain Basin. And they're colored by the size of the flood recorded in each year, with darker blue representing more extreme floods. These are recurrence intervals for gauges in the Lake Champlain Basin. This is kind of a work in progress with our students. We're still expanding this data to include gauges in the Northeast Kingdom and the southern part of the state to put on this map. But here we at least can compare the gauges in the Lake Champlain Basin. So in 2023, the larger, more extreme floods were experienced at gauges like the Moyle at Johnson, or the Winooski at Montpelier, or the Otter in Center Rutland. Whereas in 2024, the larger, more extreme floods occurred in places like the La Platte River and Lewis Creek in the Champlain Valley in the western part of the state, and along the Passumpsic River impacting St. John's Wort and Lyndonville. We're still working on those flow frequency analyses to plot those dates. We can also normalize the peak discharge that we recorded at each of these stream flow gauges by dividing them by their drainage area so that we can more appropriately compare them across watersheds of different size. And so here we see in the larger rivers, those rivers with greater drainage areas, the July 2023 event, shown again by the orange triangles, tended to generate more runoff than the 2024 or 2011 events, due in large part to that widespread and extended duration of rainfall. Antecedent soil moisture was also identified as a contributing factor in many of the reports coming out of those events. For the smaller rivers, patterns are a little more dispersed and localized. So across all events, for those smaller rivers, the steeper relief watersheds that have shallower soils or shallower depths to bedrock, rivers like the Nehaven River, for example, or the Mad River, tended to have higher runoff than their lower relief counterparts, such as the Little Otter Creek or some of the other watersheds along the Champlain Valley. We can also see the effect of floodplain and wetland attenuation, which will be the subject of next week's talks. So here we have Otter Creek at Middlebury Station. It has a much lower normalized discharge for all three events, due in large part to attenuation in upstream wetlands and floodplains. We know during Tropical Storm Irene in 2011 that discharge was greater at the upstream station in Center Rutland on the Otter Creek than it was at the Middlebury Station because of that attenuation that happened in the extensive wetlands between Rutland and Middlebury. This same phenomenon was repeated in the July 2023 events, and I think there might be a slide next week on that. The 2024 flood, remember, was pretty localized to that west to east track in the north central part of the state. And so some of these gauges never saw that kind of rainfall. Pulteney River in Fairhaven in the southern part of the state, Otter Creek at Center Rutland, for example, their 2024 flows were quite normal, quite moderate, because they just didn't see the same amount of rainfall in 2024, just a few months ago. We can also look at the stage records for each of these streamflow gauges to start to see differences in duration above action levels. So this plot shows river stage on the y-axis, and on the x-axis I've got an elapsed time in days. So essentially what I've done is pulled the stage records from each of the three storms, 2011, 2023, and 2024, and just plotted them. And I'm not so concerned that you look for any sort of correlation of one storm to another, but simply how high a stage each of these gauges reached during those events and for what duration above action stages. So USGS and the National Weather Service publish these action stages and minor, moderate, and major flood stages. Those are in horizontal gray lines on this plot. And we can see that when we pay a little bit closer attention to the 2011 storm, the duration of that storm above the action level, which is that dotted gray line there, was just on the order of maybe 3/4 of a day in length. And this was at the Winooski River in Montpelier. For the July 2024 flood, there was a similar duration, But we didn't actually, at this gauge at least, even reach a minor flood stage in Montpelier in contrast to Irene. But if we look at the 2023 event, we were at a major flood stage, exceeding a major flood stage, and the duration of that flood was on the order of 48 hours. And we had a similar response at the Lamoille River in Johnson, for example, where the July 2023 flood was the largest of the three floods and persisted for twice the duration above action stage. And this had a consequence in terms of the kinds of impacts that we saw within these river systems. The July 2023 floods along the Winooski, the Lamoille, and the Otter were of longer duration above flood stage than the floods of this past summer, and about twice the duration of flooding resulting from Tropical Storm Irene in 2011. And here we saw extended inundation flooding in places like Montpelier, further downstream in Waterbury, along Randall Street and the office complex area. In Richmond, further downstream at the interstate. Also in the Lamoille River Basin, in Jeffersonville along Route 15, downstream of it, along the same route in Cambridge, Vermont. And similarly in the Otter Creek, we saw lots of inundation flooding persisting in the fields around 3 Mile Bridge Road in Middlebury, between the Center Rutland Station and the Middlebury gauge. So lots of inundation characterizing that July 2023 event, and in contrast, and particularly along the larger rivers. Particularly though in 2024, on our smaller rivers, this is where we saw many of the impacts of flooding. Here's a couple of small rivers in the Champlain Valley, the La Platte River at Shelburne Falls and the Lewis Creek, where they saw very intense rainfall, and you can see that that reflected in the hydrograph and the very rapid rise of the hydrograph to very high stages above action levels where they were available. And this resulted in lots of flash flooding to cause erosional damages, impacting crossing structures like this undersized crossing on Spear Street in Charlotte on the morning of the 11th of July, a couple of months ago. This is on the Mud Hollow Brook, small drainage area, nevertheless very high erosional capacity to cause impacts to this crossing structure. Loss of roads like this spot in Peacham, again, a small drainage area on the Stevens River, draining east to the Connecticut River. And we saw lots of impact to homes in this July 2024 event, particularly in areas like alluvial fan settings, here in Starksboro on the upper Lewis Creek, where sediment splays and water impacted more than a dozen homes between Ireland Road and Hillsborough Road. Impacting homes in the southern part of the village in Plainfield on the Great Brook. The Winooski River itself was fairly modest in its flood heights, but the Great Brook generated lots of runoff, and I'll show a little bit more detail of that in a couple of slides. And also homes along other smaller drainages, and I'll mention that this was the 30th of July, so this was some flooding that happened a few weeks after the July 10th, 11th floods to impact Mountain Brook along the east branch of the Passumpsic in Linden, Vermont. So in all those previous cases, we could look to rainfall gauges and streamflow gauges to get a sense for the magnitude and the extent of these flood events. But often we don't have gauges available in the areas that we're studying. And so we need to rely on other techniques that are after the fact to understand the magnitude of the event. And after the floods of July this year and July last year, we deployed our students and technicians to assist towns and state agencies and watershed groups alongside other volunteer consultants and agency staff to better understand the magnitude and extent of these events, and using techniques such as high water marks and slope area methods that I'll detail in the next slides. Our technicians and students have gathered high water marks in the days and weeks after these flood events to record the maximum extent and the elevation of floodwaters. And we're using these data to calibrate and validate some of our hydraulic models. Also to verify our topographically defined floodplains, which is a data set that was released in the last couple of years from our research group, and to support indirect calculations of peak discharge by the slope area method. These data sets are being made publicly available on HydroShare, so they're available to those who might be interested to use them for their research. Here's an example of where we were helping to conduct some indirect measurement of peak discharge in Plainfield. The Winooski River, as I mentioned, was a little bit lower than it had been in 2023, preserving the north end of the village. But the south end of the village experienced catastrophic flooding from the Great Brook tributary. Several homes and businesses were damaged. The mill bridge was lost, and many segments of the Brook Road upstream from here were washed away. Now, there was no gauge on the Great Brook, so to better understand the magnitude of the flood that they experienced, we, along with others in the field, lent our services to the town of Plainfield and the Agency of Natural Resources to complement that team of volunteers from Norwich University, George Springston, from SLR Consulting, Roy Schiff, and others to perform an indirect measurement of peak discharge using the slope area method. This method relies on high water marks to define the water surface slope during that peak discharge, and also cross-sectional measurements that were surveyed to understand the area of flow, and the Manning's equation, if y'all are familiar with that, and you can come up with an estimate of the peak discharge experienced during that flood. So with our partners, we were able to estimate a peak discharge of around 1,980 cubic feet per second, which equates to a storm size between a 200-year and a 500-year for this tributary watershed. That was in line with gauged measurements of rainfall in the upper watershed, where they received 4 to more than 6 inches in that watershed over the space of 6 to 12 hours. So very intense, and on a magnitude that they had not seen since perhaps the 1927 flood. So we can begin to plot these estimates of peak discharge on our maps, and we're doing these indirect discharge measurements at a variety of locations around the state, and that will help to complement our gauging records. We're also awaiting some crest stage estimates after the new year, when USGS releases their approved records for those crest stage gauges. We have quite a network of those in Vermont, thanks to the USGS. Another type of data collection we're doing after the fact to better understand the magnitude of these events is to deploy UAS or drones to fly imagery and LiDAR in a couple of key locations, and we're comparing LiDAR-based topography before and after these flood events in order to quantify the amount of erosion or deposition that's occurring in these sites. And so here, this is an example from the New Haven River, the Saunders site, where you can see that DEM of difference on the right-hand side of the view is showing us areas that experience deposition in blue and areas that have experienced erosion in red. And we can begin to calculate a sort of sediment budget for a given reach and understand the balance of sediment that has moved through or been sourced from or has been deposited within that reach. And finally, another task that we're engaged in this fall with the help of our students is archiving and geolocating the vast amount of imagery that's now available online through YouTube videos, through Facebook, through Twitter, through traditional media accounts, And we're cataloging that imagery, geolocating it, and then digitizing high watermarks from those photos in order to compare them to our topographically defined floodplain maps, which are available for the Lake Champlain Basin. And we're currently engaged in work to expand those to other parts of the state. So we're finding that at higher recurrence intervals, our maps tend to do pretty well at predicting flooding extents, like this example here in Cambridge on the Lamoille River, which experienced between a 200 and a 500-year flood. So the closest gauge to this site that we looked to was the Lamoille River at East Georgia, where they had a 200 to 500-year event, and the extent of floodwaters is kind of mimicking our predicted 200 to 500-year flooding extent from the topo maps. For those who don't know, we do have this data set available for your research and planning efforts. Rebecca Deal has led the effort to map floodplains in the Lake Champlain Basin of Vermont using a low complexity approach to hydraulic modeling. These floodplains are not meant for any sort of regulatory use. They are intended to support research and conservation planning, but they have been used as a reference layer in the Emergency Operations Center after these or during these two flood events by state and agency folks as a way to identify those low-lying areas that are at risk of flooding during key events. Let's see. I think in the interest of time, I'll begin to wrap things up so we have time for questions. This is preliminary work. Findings so far for us, we're finding that our floodplain maps in the 200 to 500-year range are well predicting the flooding extents that we experienced in rivers in these two floods, particularly in those gauged areas that saw a 200 to 500-year flood. More importantly, anecdotally, what we're finding is that the Agency of Natural Resource river corridors that are available statewide well predicted where we had erosion hazard impacts in both of these floods. And that's a key planning tool that communities can use in order to prepare for flooding and be help to make their communities a bit more flood resilient. In general, the July 2023 flood was inundation dominated. Longer duration rainfall, more widespread rainfall was the reason that we saw more inundation, characterizing our damages in that flood event, whereas the July 2024 flood was more erosion dominated, shorter duration rainfalls, very intense rainfalls from training thunderstorms, and they were a little bit more localized. So those differences in rainfall distribution and timing seem to have accounted for the differences in impact characterization that we saw. And I just want to make a special plug for tasking the UVM Spatial Analysis Lab for overflights and LIDAR during these events. We found it to be really critical, not only for flood response in those days and hours and days after an event, but for the recovery phase that we're experiencing, where we're trying to get a sense of the impacts that have occurred and the complexity of those impacts. We heard feedback anecdotally from a lot of the smaller towns that this kind of service is really critical for their planning and for their being able to make others aware of the challenges they're facing to recover from these floods. Just having a bird's eye view of the damage and the extent of it and the complexity of it is really critical. So I would just put a plug in for the CEL's drone overflight services in not only the flood response phase, but the flood recovery phase. And finally, I'll just again highlight that next week we'll have a talk by Rebecca on the potential for our Vermont landscape to attenuate these floods and enhance the flood resilience of communities located alongside the rivers. And I'll stop there and take any questions that y'all might have.
Are there any, sorry,
That's okay.
are there any plans to do that kind of topographic flood mapping outside of the Champlain Basin?
Yes, in fact, we have engaged the UVM cell to go do some overflights in areas of the East Branch of the Passumpsic, for example, and other areas outside of the Lake Champlain Basin. And I mentioned as well that our ongoing research is targeting areas that are outside of the Lake Champlain Basin. So we hope to expand our topographically defined floodplains to other parts of the state so that they can be available as a reference layer for planning and conservation, but also potentially to guide flood response to some degree. So yes, we do. I always feel badly that so many of the past resources have been focused in the Lake Champlain Basin, so it makes an easy place to study and continue to build our knowledge of river dynamics. But there's many other parts of the state that have been hit especially hard in these two events, and so we're hoping to address that by focusing some additional resources in those areas for more study. Thank you. Anna, yeah.
So with the July 2023 floods on one end of the spectrum being more inundation based, and then the 2024 being more like erosion based, driven by differences in rainfall patterns. If you've done any looking into the December floods of 2023, where does that fall in that spectrum? And how does like the other water input from snow
great question to that? Yeah, thank you for bringing that up. So, and I do want to just say that this was kind of a broad brush that I painted these two floods with, right? That just because 2023 was inundation dominated, doesn't at all mean there were no impacts from erosion hazards, and there were some sizable impacts. Cabot Village, for example, and other places. So there, both kinds of erosion and inundation flooding were happening in both events, but one event was a little more dominated by inundation than the other by erosion. And then there was a sizable event in December 2023, as Anna mentioned, that also was fairly not as widespread as the 2023 event, but had similar amounts of rainfall, but the additional dynamic there was the snow melt, and there was a very rapid snow melt that happened alongside rainfall. And so I didn't want to complicate this presentation by talking about that event, but we are studying that event as well for the differences that it brings. And we have our students looking at imagery collected during that storm event and comparing our mapping to the flooding extents that were observed, for example. It was a different beast, though. It was we would need to bring you onto the team to help us understand those snow dynamics, Anna. Yeah.
Would you mind going back to your summary for a second? I wanted to ask you, that one, your second point, the corridors, well-predicted erosion hazard impact areas. I'm wondering if you could say a little bit more about that. And also, haven't looked at that corridor layer in a while, how far up the network it goes, and what you're thinking is about. Like, my memory is there were quite a few landslides in July of 2023.
Yes.
And that's a form of erosion that's not in the river corridor. So my question is really a little bit more expansion of what you meant by that second point.
Sure.
And you're thinking about things like the landslide occurrences, the culvert blowouts on small streams, and that sort of thing.
Yeah, thanks for that question too. I had some slides in here about landslides and I pulled them at the last minute because just to meet the time constraint, but also because I'm not the expert on the landslides. The folks at Vermont Geological Survey are the ones to come and give that webinar lecture. The 2023 July floods did have many landslides associated with them. And again, my non-expert opinion would be that it was in part because of the long duration of those soaking rains as opposed to very intense rainfall that ran off quickly. But, and I have not compared the landslides that occurred in both events to be able to make that statement or to back up that statement. But folks at Vermont Geological Survey could probably come and give a talk on that. The one thing we did notice when looking at the impact sites around the state of Vermont is that where we had erosional impacts, those were occurring in areas alongside the river that were within the state's mapped river corridors. And so to me, that suggests that we should be relying on those river corridor layers a little bit more for planning and for giving folks a heads up about what risks they might be facing. For example, this, if I can go back to this, the Mountain Brook, the case on Mountain Brook in Linden, that house was located within the river corridor surrounding that small brook. This area of Plainfield is within the mapped river corridor and experienced quite a lot of erosional flooding, undercut banks that then undermine structures. This area of Starksboro is on an alluvial fan, and a part of that area that was impacted by debris and water was within the mapped river corridor. And this as well, this area of Peacham. So these erosion hazard areas and this one here on the Mud Hollow Brook are all located within the mapped river corridor. So, it's pretty like I don't know if folks are familiar with the flood container. It was called the GIS mapping that is storing all this imagery that's being collected by the SAL, but also by AOT, but Agency of Ag and others that are collecting this imagery during the emergency response phase of an event. On that flood container, that web-based GIS project, you can pull up the layer of our topographically defined floodplains for reference. Ideally, we'd be able to pull up the layer for the river corridor, but there's a little bit of a technical glitch there. And I hope that before the next one, we can resolve that technical glitch to display river corridors on that same web-based map for reference. Yeah.
It's awesome that we've had like the indirect discharge and the UAS imagery to like help communities kind of communicate the impact. I'm curious, in working with the communities, are there any places where they feel like we could do better next time, or like things that they thought could help support the response in future floods?
What I'm hearing a lot from communities anecdotally is that especially the small communities where their emergency management person might be the third select board member on their select board and is doing this job on a purely volunteer basis. And they're not experts in flood recovery. They need more help in the flood recovery phases. So those time periods that are weeks to months to maybe up to years after the event, knowing how to deal with what's happening. So for example, in Starksboro, this situation happened the 10th and 11th of July. And those landowners, homeowners were impacted. And there was an avulsion of the channel actually, such that the upper Lewis Creek was flowing for a time in the breakdown lane of Route 116 for days. And they were just overwhelmed because they had many of the roads already eroded. They were trying to make those roads passable for life safety and health. But they had a vehicle in the channel, they had lots of large woody debris in the channel. They didn't know quite how to proceed at this site. And one of the reasons why, I think, was that they had no way to communicate easily the extent of the problem and the magnitude and the complexity. And so we helped, we in the Regional Planning Commission helped task the UVM cell to go and fly over the area at least, so that we could send a link to folks and say, look, there's a problem here, and it's a big problem, and we don't quite know how to, the town doesn't quite know how to approach it, and they need resources. And so I think and you'll notice the date on this imagery is the 22nd of July. So this was, 10, 12 days after the event. So I think what we're hearing from especially the smaller towns is needing help and support in that recovery phase in the few weeks after an event. How to triage locations, which erosional spot is more of a concern than another if that community were to experience another flood within weeks or months of that major event.
Yes, so we have about 40 people online from like DEC, all the regional planning commissions, Lewis Creek Association. So I have a few questions from everyone.
Okay.
So first, for the July 2023 flood, did you do any comparative mapping of actual extent versus mapped extent of the SFHA?
Of the special flood hazard area?
Yes.
We did not. So the questioner is asking about the FEMA special flood hazard area, which is available for select locations throughout the state, typically developed areas. And those maps are honestly somewhat outdated in many communities. They're sometimes based on survey data that was collected in 40, 50 years ago. I know that they're in the process of updating those, and that's a time and resource intensive process of updating them. But because they have a kind of spatially limited extent, we focused more so on comparing extensive flooding to our floodplain maps, which are more comprehensive and cover a larger number of river reaches.
And then Great Brook had massive erosion after the 2023 flood. Was there a conversation about future river corridor erosion predictions shared with Plainfield residents that were wiped out in 2024?
That's a good question that I don't know the answer to, actually. I would imagine that folks in the town of Plainfield would know the answer to that question, and perhaps George Springston at Norwich University, who happens to reside in Plainfield.
Yeah.
That's all I have.
Yeah, can I, this is George, if I can speak to that.
I'm just curious, looking at the fluvial erosion hazards, have you seen the correlation between the topographically defined floodplain type and where these erosions events were concentrated? So for instance, like vertically disconnected river corridors experience more erosion than
for sure. And our floodplain maps are topographically derived, and so while they're not explicitly taking into account geomorphic information that would tell us about how disconnected those channels are from the floodplain, what I'm noticing as we review these maps is that in locations where the channel is vertically disconnected from its floodplain, our mapping shows that even a 100-year or a 200-year event is going to be contained within that channel. So we're not seeing a wide floodplain in those locations, even though the valley itself is unconfined and wide. Our mapping, topographic mapping, is showing the 200-year, the 100-year floodplain being contained wholly within that channel. And so those locations where are where we're seeing coincidentally also erosional hazards. Like I don't have a slide here, but I can think of a case in Hardwick where they experienced quite a lot of erosion, and our mapping shows a very skinny floodplain through there in that unconfined setting. So we haven't quantitatively looked at that though to correlate that.
related to Alexander's question, have you looked at your channel classification system that you derived for your PhD and how well that correlates to
We
damages?
are in the process of doing that as we speak, with Alexander's help, to try and tag these floodplain reaches with the sediment regime classes that we've generated in past research, and begin to make some of those correlations in a more comprehensive way, in quantitative way.
No chat. How can regional planning commissions obtain data on the extent and location, not the depth of how far flooding exceeded the boundaries in the special flood hazard area?
Okay.
Right, yeah, so we can help towns communicate that risk and memorialize it before it's forgotten.
Okay, I would suggest even just hopping on the floodplain container, which I can provide a link to. I don't know how we get it to everyone that's online there or the person that's asking. But if you log on to that floodplain container, you can actually pull up reference layers, including FEMA special flood hazard areas where they exist, including our topographically defined floodplains, and begin to then get a sense for where the damage, overlaid on top of that is aerial imagery and oblique imagery and even videos in some cases of where the damages occurred. And so you can start to compare and contrast those. Maybe what might be helpful is here at UVM, we could create a little how-to or a tutorial of how to do that and share that with the regional planning commissions, if that would be helpful.
And let me just add, we've also surveyed a bunch of the inundation extents, and we've published some and some to come, and are, as Kristen talked about, digitizing the extents from that container.
Yeah.
So that will ideally be a data set that will be really, so that can kind of be layered on top of each other to understand those areas.
Yeah, great point. That'll be in the next year or two, we're hoping. But more immediately, we could provide a tutorial of how to access those layers on the flood container.
If you did that, we could send it out to the mailing list to which we distribute the seminar series.
That would work. There we go. Excellent.
I think that's all I have, except a comment from George that did say Plainfield was starting conversations on how to better deal with flooding and erosion problems when we were hit by the July 2024 flood. The recovery is long and difficult, and the UVM's cell group was really helpful after both of these events.
Yeah, for sure. Can't say enough good things about the spatial analysis lab.
Hey, Kristen, this is Stacy Pomeroy. I put on the chat a quick PDF of the Great Brook, some comparison of the between the flights and also where the river corridor was used through the change in Great Brook. So for those online, you can see the PDF of that change.
Forgot about this part.
We don't do this in Arizona.